So now in this video we're going to do another integrated circuit, this time looking at the NOR gate. So I'll explain what that is coming up in a little bit, but we have a couple of inputs, and depending on whether their voltage is high, relatively close to 5 volts, or low, relatively close to 0 volts, ground, that will determine the output. And we'll come to that a little bit more. So the integrated circuit we're going to look at is the 74HC02. And it's a 7400 series integrated circuit. 02 is the quad NOR gate, and HC stands for high speed CMOS. So we'll come back to that in a little bit. But in any case, with this circuit, so we got the inputs that look at the voltage. No current goes in or out other than a little trickle, but generally speaking, no current in or out of the inputs. The output, of course, does sink or source current. So when the output is low, here you can see we have a blue LED. I actually swapped the position on the breadboard where the resistor and the LED are. They're swapped, but the cathode is headed towards the output and anode is headed towards the 5 volt supply for the blue LED. We're using a higher value resistor because blue LED is naturally brighter than red LED. Only use 220 ohms. But in any case, when the output's low, you can see here we'll have a current path through the blue LED. It will light up. When the output is high, as close as it can get to 5 volts there, then the red LED will light up. So let's look at what makes the output high or low. So here we have a truth table, which you want to look up for any logic gate that you are not familiar with. So we have the A and B inputs and then the output Y right there. So an OR gate instead of NOR, an OR gate, if one, the other in this case, since there's two inputs, or all of the inputs are high, then the output would be high. But since this is a NOR gate, that means not OR gate or inverted OR gate, the output is inverted. And so instead of the output being high when one or more input is high, it's low. And if all of the inputs are low, instead of being low like the OR gate, the NOR gate is high right there. So that's the rules. And again, high or 1 means close to 5 volts, 0 or low means close to 0 volts, depending on the particular integrated circuit you are using. But in any case, we got two states, and so they don't have to be defined terribly well. It's pretty clear when it's high or low for the most part, and close to 5 volts or close to 0 volts. So I wrote those notes over there, 7400 series integrated circuit, that's what the 74 is, and it may or may not have letters, but the high-speed CMOS version is the main one right now. So you'll see that a lot, 74HC. And then 02, the last two digits, let you know the type of integrated circuit that is on there. So it's quad, there's 4 of them, 1, 2, 3, and 4. 2 inputs, so input A and B, NOR gates. And we already talked about the NOR gates. So now, we don't want to leave any unused inputs floating. So all of these inputs, you'll see I tied to one power supply or the other. You could also use a resistor to put them to the power supply, but you can connect them directly to the power supply. Again, current doesn't go in or out of them. The outputs you can leave floating, that's okay. You don't have to connect them to anything unless you want to connect them to something. The voltage we're going to use is 5 volts, which is pretty much always, if not always, a safe voltage for these integrated circuits. They're generally made for 5 volts. The high-speed CMOS version, though, of the 7402, we can work with 2 to 6 volts safely. So that's not even the absolute maximum voltage range, but that's recommended right there, 2 to 6 volts. And for the high-speed CMOS version, again, we can sink or source 25 milliamps of current. So that's quite a bit of current for a lot of these 7400 series integrated circuits, and so it's a pretty nice circuit to work with. So now we come to the breadboard, and just in case I forgot to mention it, I think I did, always consult the data sheet of whatever part number you are using. Look this up. I'm actually using the N. There's an N after the number there, but that's not terribly important. That probably means it's slightly improved from the basic version. But in any case, we need to power the integrated circuit, so VCC is the positive supply. As you can see, we got a jumper to the positive supply there, going to pin 14 up there. Pin number 7 down on the bottom left, so we got 1 down to 7, and then we got 8 working our way up to 14. So pin number 7, ground, we got to ground again. Now, I mentioned not to leave inputs floating, so that's why you see these other pins going to the power supply. And to save on grabbing more of these jumpers, these gray ones and this yellow one, I just grabbed a little jumper there. Plus, some of these inputs are right to kind of a dead spot. Makes it a little hard to tie them to a power supply. Not terrible, but a little bit harder. So I just took a little jumper so the positive supply comes over, and then it comes down here. I used the positive supply up there because we got ground down here to help to keep them distinguished. And then we got ground over here since we got the positive supply up there, and a little jumper. So let's look at the rest of the main circuit. The inputs, pretty straightforward. We got a trim pot right there. Middle pin is the wiper, so that slides across the resistive element. It's going to B, so it's output Y, and then A, and then B right there. And then the other two ends of the resistive element are connected to the positive supply. So up there is high, close to 5 volts, and then we get about halfway, it'll go low after we get a little more than halfway to ground, down to 0 volts right there. I have a jumper, as I said before. I can move it back and forth between the two supply rails to give 5 volts or 0 volts for a more distinct voltage there. Then we have at the output the LEDs. As I mentioned before, I swapped the position with the resistor and LEDs, but they're in series, and so it doesn't matter which comes first as long as the LED is in the right direction. So output 220 ohm resistor, long lead the anode right there, that part of the triangle, to the resistor. Short lead, the cathode, is going to ground right down there. I got a jumper going to ground. And then the blue LED, again, the long lead, the anode, needs to be more positive. This is always the case. Short lead, the cathode, more negative, so it'll light up when the output is low or more negative down there. So that's shorter lead to the resistor, longer lead above there. Now we will grab the power supply and pull back and look at how this is working. So hopefully the light is better there. Right now the output's off. I have it set to 5.1 volts, and which should still be safe for probably all of these integrated circuits, 7400 series. I'll hit the power button, and now the power is on. So as we said before, for the output to be high, both of the inputs have to be low. And so we know that one or the other is high. I can see this jumper is low, and that one's high. If I go low now you can see it's high. And as I said before, the red LED is not as bright. This current is pretty much all the LEDs, plus this isn't completely accurate, but it's close enough. But you can see we got a lot more current when the red LED is lit up than the blue LED, just because the blue LED is naturally brighter right there. So, in any case, that's enough for the power supply. Limited current to 20 milliamps, just in case I mess something up. Hopefully I won't fry anything. And sorry about the mess over here. So, we'll get closer now. And so we got them both low. But if that one goes low and that one's low, we got the output high. And then if we get the output high, see, this is why you don't leave inputs floating. It makes the output erratic. It'll probably bounce back and forth between two states. So that's why all these other inputs are tied to a power supply rail. Now we have a positive there, but low down here. So doesn't matter what we do now with this one. We have a high input, so the output's going to be low no matter what, whether or not the other input is high or low. Now with these integrated circuits, it's a good idea to look at how the input responds. It's really clear if it's 5 or 0 volts, and it's good to get an idea where the middle ground, how that's going to work. So I'm going to slowly go up, and I think we'll see the blue LED kind of turn on while the red LED is still on. There we go. Yeah. Now, working our way back down, looks like it has more of a Schmidt trigger effect, where it kicks in right away, goes to red right there. And maybe not quite, but it looks like it goes to red easier than from blue than it does to blue from red. So, in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. If you can't subscribe, please do. I have links down below, but otherwise, I really appreciate that you watch these videos. Thanks for watching them. I'll see ya in the next video.